Good evening everyone, good evening. I welcome you all again to the JEE Enthuse. Hope you guys are doing good. Well people, if I'm audible and visible to everyone, let me know in the chat box with the thumbs ups. Let me know in the chat box with the thumbs ups if I'm audible and visible to everyone right here. Hi Rashid, hello Ashwarya, good evening, welcome to the session. Welcome guys, welcome to the session. Well, let me know if I'm audible and visible to everyone. Hi Neha, good evening. Alright, so people, as you all must be knowing, today we are going to do the last minute revision from the chapter Thermodynamics. Yes, it is going to be the revision session from the chapter Thermodynamics, in which I have come up with around 15 questions, which is going to revise your whole Thermodynamics chapter. Yes. Okay, so before starting the session, let me introduce myself. As you all must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. Okay. Well people, this is the schedule of the week which I've been following throughout. Yes. Well, today we are going to do the Thermodynamics last minute session, right? And tomorrow it's going to be solid state. On Saturday, it's going to be the JEE Mains 2021 mock test, and on Sunday, it's going to be most expected questions for JEE Mains 2021 first attempt, right? So do not miss this session at all, as well as this session, yeah? All right. Yashwini, I'm doing wonderful. How are you? Hi, KM Singh. Welcome to the session, guys. Well, have a look on the schedule again, guys. Today, it's going to be the last minute revision from the chapter Thermodynamics. Tomorrow, it's going to be solid state. On Saturday, it's going to be JEE Mains 2021 mock test. And on Sunday, it's going to be the most expected questions for JEE Mains 2021 first attempt, right? Okay. Well, for the ones who have no idea about the Vedantu JEE 2021 crash course, which we have started on the actual Vedantu platform, well, people, let me give you the introduction of this crash course right here. Okay, what all benefits you guys are going to get if you'll enroll yourself in this crash course. The first and the important benefit is that you guys will be trained by the teachers of your choice. Yes, and at the same time, we are going to cover your whole syllabus before your JEE 2021 examination. Apart from that, no need to worry about the test series, no need to worry about the mock tests. Everything is included right here in this crash course, right? And people, at the same time, there will be some extra sessions as well regarding the time management from our experts, and at the same time there will be some extra sessions by means of which you get to know how to solve the questions in lesser time, right? And at the same time, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers. Yes, so well, do get enrolled in this, and there's a link in the description box of the video. I want you guys to click on that link. Use the coupon code as WSCC. On using the coupon code of WSCC, you guys will be getting 20% off, and after the 20% off, you guys are just getting this crash course for 8K, right? And if you want me to train you personally for chemistry, do not forget to use the coupon code as WSCC right here. Yeah. Okay. Well, people, about the Eklavya batch, as you all must be knowing now, as you all must be familiar with the fact that we are starting the Eklavya batch again this year for the JEE advanced people, right? And let me show you the course details of this. There will be 70 live sessions, 3000 plus advanced level questions, 18 JEE advanced test series, and 6 JEE main series. And the batch dates: on 8th March, we are going to start the first batch. 19th March, it's going to be the second batch, then 1st May, then 29th May, right? So there is a link in the description box of the video for this Eklavya batch wherein we train the JEE advanced kids properly. Yes, and people, as you all must be knowing, in 2020 we got around 558 selections from this particular Eklavya batch in JEE Advanced, right? And among those 558 selections, there were 10 people whose rank was in top 100. Yes, guys, that's actually immense, right? So do get enrolled in this, and there is a link in the description box of the video as well. This is completely free of cost, yeah? Okay. Well, for the ones whose preparation is up to the mark, we have come up with a test series for them, a separate test series. If you do not want to get enrolled in the crash course, you can opt for the JEE Mains test series as well. Well, people, in this JEE Mains test series, what you'll be getting the full length tests, right? And keeping in the mind the pattern of JEE Main 2021. And at the same time, how many tests are included in it? There will be 20 full length tests and 10 tests before February attempt and 10 tests for the March attempt. So do have a look on this. Do get enrolled in this. If your preparation is up to mark, you just want to solve more and more questions, do get enrolled in this, wherein you get to know the time management, you get to know how to solve the questions in lesser time. Everything will be done in detail, right? Okay, well people, these are your physics, chemistry and maths teachers who are going to have the paper discussion, test series paper discussion with you after every paper. Yeah, okay. Well, there's a link in the description box of the video as well for this test series. You just need to apply the code as WSCC in order to get the 20% off, and after the 20% off, you guys are just getting it for 1999. Yes, link is there in the description box of the video. Welcome guys, welcome to the session, everyone. Welcome to the session. Naveen will be starting that soon, bro. Yeah, right now let's focus on JEE Mains 2021 first attempt, right? Let's focus on that first. Yeah. Good evening, official gamer. Good evening, good evening, good evening. Good evening. Yes, RG dubs, I'll be doing that, right? Okay, well people, for the ones who have not liked the video yet, do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, okay? So let me know in the chat box if you guys are super duper excited for the last minute revision of the chapter Thermodynamics for the upcoming JEE 2021, right? Well people, I've come up with 15 questions. By solving these 15 questions, you will be revising your whole thermodynamics chapter right here. Welcome Amir, welcome to the session. Let me know in the chat box if you guys are super duper excited for the session. Hi Shab, hi, welcome to the session. Hi Pramesh, welcome to the session guys, welcome. Subhash, that's actually good, bro. Keep it up. Just shoot the rank up. Yes. Let me know in the chat box if you guys are super duper excited to start the session. Yes. Let me know in the chat box. So let's get started with the first question, which is on your screen now. Well people, all the questions which I'll be solving in the today's session, all these questions have been asked in JEE Mains in different years. Yeah, so this is the first question which you guys are going to solve right here. Let me know its answer fast. Delta U is equal to isochoric work, isobaric work, adiabatic work and isothermal work. What do you think should be the answer? I want everyone to type the answer. Whatever you think, just type it. Let me know about it. Let me know fast. This is the first question on your screen. Delta U is equal to isochoric work, isobaric work, adiabatic work and isothermal work. Well, Amir is saying it's option C. Samshad is saying it's option C. Amir, walaikum salam. Okay, Shoaib is saying it's C. Mateen is saying it's C. Well, I can see all the C's coming up, right? Okay, Javed is saying it should be C. DX it should be C. Well, people, let's get to know what the answer exactly is. Delta U, as per the first law of thermodynamics, all of you must be knowing delta U is equal to Q plus W, right? We need to check delta U is equal to. People, when will be the value of delta U equal to W? When Q value will be 0, right? I can simply say delta U is equal to W during which process? During the process in which Q is 0, that means during the adiabatic process, yes. So I can simply say delta U is always equal to adiabatic work right here, yes. So the correct option was supposed to be option C. Delta U is equal to the adiabatic, wherein Q value is 0, and if Q is 0, delta U will be simply equal to W. That means change in internal energy is actually equal to adiabatic work right here. Yes, right. I hope this is clear to everyone. Let me move on to one more question, guys. Which is on your screen now. Yes. Well, this question was again asked once in your JEE Mains, right? Molar entropy and temperature R. Intensive properties, extensive properties, intensive and extensive respectively. Well, people, let me give you the introduction of extensive and intensive properties. Extensive properties are the ones whose value changes on changing the size of the system, whereas intensive properties are the ones whose value do not change on changing the size of the system, right? Well, people, this is the molar entropy. Do not forget it. This molar entropy, this entropy per unit mole. Yeah. Yes. If it was only entropy, then definitely entropy, only entropy, not the molar entropy. Only entropy would have been the extensive, but this is molar entropy. Yes, this is entropy of the substance per unit mole. Whenever the extensive property is expressed per unit mass, per unit mole, or per unit volume, it becomes intensive. Yes. So people, your molar entropy right here, that means entropy per unit mole, and temperature, these are the intensive properties whose value does not change on changing the size of the system, on changing the amount of substance present in the system. Yes, a very, very simple question this was. Yeah. Well, I can see majority of the people saying option A. Exactly, guys. All of you are perfectly correct. Yeah. Okay. Let me move on to one more question then. Let me see if you can solve this or not. Have a look on this, guys. 5 moles of an ideal gas at 100 Kelvin are allowed to undergo reversible compression till its temperature becomes 200 Kelvin. If CV is 28 joules per Kelvin per mole, calculate delta U and delta PV for this process. Let me know in the chat box what do you think should be the answer. Yes. Let me know. Amir is saying option C. Hi Nana, how are you doing? Let me know in the chat box what do you think should be the answer. Let me know fast. Yeah. I want every one of you to give it a try and let me know the answer in the chat box right now. Well, I can see a lot of C options are coming up. Is that? 5 moles of an ideal gas at 100 Kelvin are allowed to undergo reversible compression till its temperature becomes 200 Kelvin. Calculate delta U and delta PV for this process. Let's get to know how this question is to be solved. The first thing, we are supposed to calculate the value of delta U. As people, you all must be doing delta U for the ideal gas is always equal to NCV delta T, which is T2 minus T1. Yes. What is the value of N? N means number of moles of the ideal gas, that is 5. CV value is given to us, that is 28 joules per Kelvin per mole. Final temperature minus initial temperature. Final is 200, initial is 100. Final minus initial, that's going to be 100. Just calculate it, get the value of delta U, right? Just calculate it, get the value of delta U. So right here, you'll be getting it as 14,000 joules. So which is going to be simply 14 kilojoules. Yes. So delta U value you got to know as 14 kilojoules, right? Right? Yes. Now people, the second part of the question, calculate delta of PV. Calculate delta of PV. People, delta of PV, can I say it's going to be equal? Can I say it's going to be equal to NR delta T, right? Can I say delta of PV is going to be NR delta T, right? Very, very simple. Yes. N value is given to me as 5. Yeah. N value is 5. R value is 8.314 and delta T is going to be final temperature minus initial temperature. Final temperature is 200, initial is 100, so it's going to be 100 right here. So value you'll be getting in joules right here. Yes, you'll be getting the value in joules and you'll be dividing it by 1000. Then you'll be getting the value of delta PV in kilojoules right here. Let's get the exact value. See guys, NR delta T. N value is 5. R value you're taking as 8 and final temperature minus initial temperature right here, you are getting the answer as 4000 joules, which is going to be 4 kilojoules right here. Yes, this is the value of delta of PV. So option C was supposed to be correct one, in which delta U is 14 kilojoules and delta of PV is 4 kilojoules. Yes, right? Madeen, I'm doing wonderful. I am doing wonderful. Yeah. Let me know in the chat box if it is clear to every single guy so that I can move on to one more question right here. Let me know in the chat box with the thumbs ups so that I can move on to one more question right here. Let me know in the chat box. Let me know in the chat box. Yes. Should I move on to one more? Let me know fast. All right. Let's move on to one more question, guys. This is on your screen. Have a look. A piston filled with 0.04 moles of an ideal gas expands reversibly. So first thing, expansion is happening, and whenever there is expansion, work is done by the system, and whenever work is done by the system, W value is taken to be negative in chemistry. Yes. So first thing, W value will be negative, right? Well, people, in doing so, it absorbs 208 joules of heat, right? During this expansion, the system is absorbing 208 joules of heat. And we know whenever the system absorbs heat, Q value is taken to be positive. So Q value is equal to plus 208 joules. Yes. Q value is equal to plus 208 joules right here. Yes. And people, the process is taking place at constant temperature. That means it's going to be isothermal. And in case of isothermal process, as you all must be knowing, delta U is 0. If delta U is 0, I'll say Q will be equal to minus W. Yes. Q will be equal to minus W, or I can say W value will be equal to minus 208 joules. So Q value will be equal to plus 208, W value will be equal to minus 208. Just see which option satisfies it. Yes, option A satisfies it, so it's going to be correct among all. Yes. Let me know in the chat box how many got it right. Let me know in the chat box how many got it right. Let me know in the chat box. Let me see how many among you got it right. Let me know in the chat box. Let me know in the chat box, yeah? Let me know in the chat box. Wonderful. Good going. Good going, yeah. All right. Let's move on to one more question, which is on your screen now. Well, I think this is the same question. Is that? No, it's different. Okay. 2 moles of an ideal gas are expanded reversibly and isothermally from 10 atm to 5 atm. 10 atm is the initial pressure of the system, which I'm representing as P1, and this is P2, correct? At 27 degrees centigrade, this is the temperature. It's given to me as 300 Kelvin, correct? 27 degrees centigrade. What will be the value of Q, W, delta U, and delta H in calories? Yes. Let me know in the chat box. Let me know in the chat box what do you think should be the answer. Well, Amir is saying it should be A. Right? Amir is saying it should be A. What about the rest of the people? Well, Shoaib is saying it should be A. I want answers from every single guy. Let me know fast. Yes. Farooq says it should be A. DX says A. Nana says it should be A. SL says it should be A. Okay. Javed says it should be A. Well, then A must be the answer if you think it's A. Yeah. Well, people, the first thing which you need to identify right here, the process is isothermal, right? An ideal gas is undergoing isothermal process. And remember, whenever the ideal gas undergoes isothermal process, delta U as well as delta H for the gas is 0. Because delta U for the ideal gas is NCV delta T, delta H is NCP delta T. Since process isothermal, temperature is constant, delta T is 0. So delta U as well as delta H both will be 0. First thing, yeah? Right? Now the point is to calculate Q and W, right? Well, people, in the isothermal reversible process, how do we calculate work? It's going to be minus nRT ln of P1 divided by P2. This is the formula by means of which we can calculate the work done in reversible isothermal process. Yes. So isn't it simply going to be minus times N value? N is number of moles of gas, which is 2. R value I'll be using as 2 calories per Kelvin per mole. Temperature is given to me as 300. It's going to be ln of P1 by P2. Ln of 10 by 5. 10 by 5 is 2. So ln of 2. Ln of 2 is given to me as 0.7. Right? Multiplied by 0.7. So what will be... what you guys are going to get? 2 to 4, 4, 3, 12. 1200 multiplied by 0.7 is minus 840 joules right here. Sorry, calories right here. Yes. So this is the value of W. So if you got the value of W, then Q we know is equal to minus W in case of isothermal process. So Q is going to be 840 calories right here. Now we will check the options. Q is supposed to be positive. Where is Q positive? Q is positive. W is negative. Delta U is 0. Delta H is 0. Yes, option A is the one which is going to be correct among all. Yes. Right? Wonderful. Wonderful, guys. Okay. Yes, Valugula. Yes, I'll be doing that. Well, let's move on to one more question which is on your screen now. This question, an ideal gas expands in volume from 1 in 10 power minus 3 meter cube to 1 in 10 power minus 2 meter cube at 300 Kelvin against constant pressure, guys. Against constant pressure of 1 in 10 power 5 Newton per meter square, the work done is, right? I've told you in detail. If you do not remember one important thing right here. Whenever expansion will be done against constant external pressure, whenever in a question you'll be mentioned with the fact that expansion is happening against constant external pressure, you are going to take the process as irreversible. Yes. And people, if you remember, how do we calculate work done in irreversible process? The first thing, the general expression to calculate work is going to be, minus integral V1 to V2. It's going to be P external dV. Since external pressure is kept as constant, so W in irreversible is going to be minus P external, I'm taking as common. This is going to be delta V, that means V2 minus V1. I think every parameter is given to me, right? So it's going to be minus P external is going to be 10 power 5 Newton per meter square. Right? V2 minus V1. V2, final volume of the system, that is 10 power minus 2 minus initial volume of the system, that's 10 power minus 3. Just calculate it, get the work done in joules. Yes? Right? Well, the equation is dusted, right? The equation is dusted. Simple calculation, a bit of calculation is needed. It's going to be minus 900 joules right here. Yeah? Minus 900 joules right here is going to be the work done in this irreversible process, correct? I'm sure this is clear to every single guy, yeah? Pramesh, bro, how many mock tests you can solve? Just do that. Just do that. Only now solve only mock tests. Only mock tests will help, right? No need to study anything new right now. Just try to solve majority of the mock tests. Just try to do the questions so that you get to know the time management properly. That is actually very important when you write in the when you sit in the competitive examination, right? That is the most important thing, right? How do you manage time, which you'll be only getting to know by solving a lot of mock tests, right? So I actually want you guys to solve a lot of mock tests so that you get to know properly the time management so that you can give like proper time for the every question, right? Okay. Wonderful. Let's move on. Let's move on to one more question. This is on your screen, guys. Have a look. This was also asked once. I don't remember the year in your JEE mains. Yeah. Very simple question. This is just you need to understand. Just you need to understand. Just you need to understand it. That's it. Yeah. 1 mole of a non-ideal gas, right? That means he's talking about a real gas. Yes. That means we have got a real gas in the container. Yes. Well, people, the number of moles of real gas is given to me as 1 mole, undergoes a change in state from 2 atm, 3 liter, 100 Kelvin. So this is initial pressure of the gas. This is initial volume of the gas. This is initial temperature of the gas. This is final pressure of the gas. This is final volume of the gas. This is final temperature of the gas. So a non-ideal gas is undergoing a change in state with a change in internal energy. Delta U is given to us as the change in enthalpy in the process will be. Yes. A very, very simple question again. Well, people, the relation which I'm going to use right here is going to be delta H is equal to delta U plus delta PV. Yes. This is valid for you, all your ideal gases as well as real gases, right? Correct. So I'm going to write something like this. Delta U is given to me as 30 atm liter plus delta of PV means P2 V2 minus P1 V1. Yeah. It's going to be P2 V2 minus P1 V1 right here. So 30 atm liter plus P2. What is the value of P2, guys? Value of P2 is 4 multiplied by what is the value of V2? V2 value is 5 minus P1 V1. P1 value is 2, right? V1 value is 3. Yes, V1 value is 3. So you'll be getting it something like this. 30 plus it's going to be 14 and the answer is going to be 44 atm liter, right? Is there any option satisfying it? Just check it out. Just check it out. Exactly, guys. Option C is the one which is 44 atm liter right here. Yes. Right. Two 2.0. Silda, you can mark it as 2.0. That's it. Yeah. Okay. Well, the question is dusted. Let's move on to one more then. I'm sure this part is done. Okay, one more question, guys, from the concept of Gibbs free energy. I'm sure you can easily kill this question. And this was also once asked in your JEE. Just kill it right now. Kill it right now. Let me know the answer in the chat box. Let me know the answer in the chat box. You can do it, guys. Give it a try. Give it a try fast. It's a simplest question which you can ever get from the concept of Gibbs free energy, yeah? Right? Well, people, as you must be knowing, delta G is equal delta H minus T delta S, yeah? Delta H minus T delta S. So A right here is going to be delta H and B right here is going to be delta S, correct? Now check the options, The process is going to be endothermic. Is A is less than 0? A is less than 0 means delta H less than 0. No, we know for the reaction was delta H is less than 0. That is exothermic, that's not endothermic, right? Exothermic when B is less than 0. B means entropy change. It has got nothing to do with whether the process is exothermic or endothermic, right? The next question, the next part is exothermic if A is greater than 0. Let's check. No way. The last one is endothermic is if A is greater than 0. Absolutely, it's going to be endothermic if A is greater than 0. A means when delta H is greater than 0 for the process was delta H is greater than 0, A is greater than 0. I'll say that's going to be endothermic. Yes, based on the sign of delta H, we classify the reactions into two types. We classify the process into two types. One is called as endo and exo. If delta H is positive, that's going to be endo. If delta H is negative, that's going to be exo. So the last one is supposed to be the correct one among all. Yes. Right? Exactly. Let's move on to one more question which is on your screen. Let me see what do you think should be the answer. A system expands from 5 liter to 10 liter against a again it's mentioned as against a constant external pressure. And few minutes back I told you whenever in a question you get a statement as constant external pressure, understand the process is going to be irreversible. Yes. So right here the process is irreversible. If it absorbs 800 joules of heat during the process, choose the correct value of delta U. Right? Right? What should be the answer, guys? Let me know in the chat box. Farooq, I didn't get you. What same questions you are saying, bro? I don't remember whether I've solved this question before. Well, Nana is saying it should be B. Shab is saying it should be B. Dani is saying it should be B. Farooq says it should be B. What about the rest of the people? Let me know, guys. Let me know fast. No, Mohsin, not yet. I'm waiting for your answers, guys. Javed says it should be B. Well, there's only one thing where you can do the mistake. That's it. Only one place where you can do the mistake, yeah? That is the units. That's it, yeah? Let's get to know what the question says and how it's to be solved. We know, guys, delta U is equal to Q plus W, right? We are supposed to calculate delta U in joules, yeah? So delta U we are supposed to calculate in joules. It's going to be Q. The system is absorbing 800 joules. So it's going to be plus 800. Yes, with this you are writing the units as well, joules. Plus W is minus P external delta V minus P external. It's going to be 2 atm. So minus times 2, right? Multiplied by delta V. Final volume minus initial volume. 10 minus 5, that is 5. But it's going to be in atm liter. It's going to be in atm liter, and as you all must be knowing, 1 atm liter is equal to 101.3 joules. So delta U in joules is going to be equal to 800 minus, this is going to be 10 multiplied by 101.3, but this is going to be now in joules. This in joules, this in joules. So you are getting delta U right here as minus 217 joules, right? I think this is the correct one among all, right? Yes. A very, very, very simple question this was. Yes, Martin, first law of thermodynamics, right? Okay, let's move on to one more, guys. Let's check one more question. Okay, this is one more question, guys. I want you guys to give it a try. When 500 calories heat is given to the gas X in an isobaric process, pressure is remaining constant, yeah? Its work done comes out to be, its work done comes out as 142.8 calories, the gas X will be. What do you think should be the answer? How do you think should we solve this one? Have a look. First of all, 500 calories of heat is given to gas X in an isobaric process. So QP value is given to us as is as 500 calories. And QP, all of you must be knowing, that is NCP delta T. QP is equal to NCP delta T. It's given as 500 joules, right? Work done comes out to be 142.8 calories. In an isobaric process, how do we calculate work? It's going to be minus NR delta T. I hope you remember that. Yeah, minus NR delta T. So W is going to be simply, or you can write it like this. W value is given to us as 142 calories. Yes, 142.8 is given to us as minus N. N value, is it given? N value is given, is that? No, N value is not given. So what I can do right here is I can eliminate delta T from here. Can I say delta T is going to be 500 divided by NCP? Right? So I can put the value of delta T over here in this equation. So it's going to be minus NR delta T. Instead of delta T, I'm going to write 500 divided by NCP. Correct? Can I say N and N got cancelled? So I get the value of CP right here as minus 500 divided by what? Wait guys, minus 500. Is that? Well, isobaric process W is equal to NR delta T, right? When 500 is given to this in an isobaric process, work done comes out to be 142.8 calories. The gas QP is equal to NCP delta T. Delta T I'm getting as 500 divided by NCP. W is equal to minus NR delta T, right? So it's going to be W is equal to this is equal to minus NR. So CP, okay, I need to get the CP value. Okay, 500 divided by what? 500 R divided by 142.8, correct? Now, R value you can keep it as 2, so it's going to be 1000 divided by 142.8, which is going to be around 7. So CP value you are getting around as 7. If CP value is coming as 7, which gas has got the CP value as 7, guys? Do you remember? Right? Do you remember? For which gas CP value is 7? Diatomic gas, guys. It's going to be oxygen, right? A simple question this was, correct? Right? Yes? Let me know in the chat box if it's clear to every single guy. Let me know fast. CP value is coming as 7. That indicates the gas should be diatomic. Hence, it should be oxygen. Yes? All right. Let's move on to one more question which is on your screen. The entropy change involved in the isothermal reversible expansion of 2 moles of an ideal gas from a volume of 10 decimeter cube to volume of 100 decimeter cube at 27 degrees centigrade. If you just remember the formula, you're done. Right? If you just remember the formula, you're done. Well, people, it's very simple. If you remember, delta S for the gas is going to be 2.303 NR log of V2 divided by V1 for the isothermal process. I hope you remember this formula, correct? Well, I'm given with the initial volume as well as final volume. This 100 decimeter cube, that means 100 liters is the final volume, 10 liters is the initial volume, right? So I'm given with the final volume as well as initial volume. I'm given with the temperature. Every parameter right here is given to me. So I'll be putting all the parameters into this equation. I'll be simply getting the value of delta S, which I'm supposed to calculate. The question is done and dusted. Just the formula based question, guys. That's it. Formula based question, right? It's going to be 2.303. N stands for number of moles of gas. It's given to us as how much? For 2 moles. N value is 2. R value I'm using as 8.314 joules per Kelvin per mole. Log of final volume divided by initial volume. Final volume is 100 decimeter cube, which is 100 liters. Initial volume is 10 liters. Just solve it out. You're done with the question, right? Just the formula based question. That's it, right? That's it. The question is dusted. I'm moving on to one more question, guys. This is the question on your screen, and let me know what do you think should be the answer. In an isothermal expansion of 1 mole of an ideal gas against vacuum, right? So that means this is the free expansion, guys. Expansion against 0 external pressure. Expansion in vacuum is what we call as free expansion, right? Well, the quantity of heat absorbed by the gas will be a very, very, very simple question, guys. Just you need to use your brain a bit, yeah? Jaldi batao iska answer kya hoga? Jaldi. I want answers from every single guy right here. Let me know. Amir is saying it should be B. What about the rest of the people? What do you think should be the answer? Let me know fast. Pramesh says it should be B. Dani says it should be C. Danween Kumar says it should be A. What about the rest of the people? I want everyone to get involved, guys, in this question. Let me know the answer in the chat box. Well, Neha, you can go for N Avasti. Yes. Well, Shamshad is saying it should be B. Pramay says it should be something 0. Farhan says it should be C. Let's get to know. Atif says it should be B. Mohit says B. Shriram says C. Bala says it should be A. Let's get to know. Akib says it should be B. Okay, guys, it's a very, very simple question. First thing, we are doing the expansion in vacuum. That means we are talking about free expansion. And whenever there is free expansion, W value is taken to be 0. Expansion against 0 external pressure, there we always say W value is 0, number 1. And this expansion is taking place at constant temperature, guys. Yes, it is taking place at constant temperature. So during this expansion, I'll say delta U will be also 0, because we know whenever the ideal gas undergoes the isothermal process, delta U for that ideal gas is 0. Now, if delta U is 0, W is 0, as per first law of thermodynamics, delta U is equal to Q plus W. Since delta U is 0, W is 0, I'll simply say Q value is 0, right? So which option satisfies it? The quantity of heat absorbed by the gas is equal to 0, which is the option B, right? Let me know in the chat box. If you got it. Let me know if you in the chat box if you want me to move on to the next question fast. Yes. Yes, Gala, you are a bit late, but no issues. You can watch the session again. Just pull the video a little back. Right, absolutely. Let's move on to one more question, guys. Let me see if you can solve this one or not. Okay, give it a try, guys. The internal, this was once asked in JEE as well. Okay, the internal energy change when the system goes from A to B is 40 kilojoules. If the system goes from A to B by a reversible path and returns to state A by irreversible path, what will be the net change in internal energy? What do you think should be the answer? Let me know in the chat box right now. Yes. Let me know in the chat box right now. Well, we need to calculate the change in internal energy. People, do you remember internal energy is a state function and state functions are path independent? If internal energy is a state function, it is path independent. It's path independent, right? The net change in internal energy is going to be 0 because it does not depend on the path followed, right? Yes. State function is the one which only depends on initial and final state of the system. It does not depend on the path followed to change the state of the system. Yes. So it's going to be D. Delta U value change in internal energy is going to be 0 right here. Yeah. Yes, absolutely, guys. Let's move on to one more question. Consider the reaction this carried out at constant temperature and pressure if delta H and delta E are the enthalpy and internal energy. Okay, which of the following expression is true? What do you think? A very simple question from the relation between delta H and delta U. A very, very simple and ordinary question this is. And again, this question was asked in your JEE once, yeah? I'm sorry. Let me know fast. Well, people, have a look. This N2 is in gaseous state, H2 is in gaseous state, NH3 is in gaseous state, right? So first thing, I'll be calculating delta Ng for the reaction. It's going to be number of moles of gaseous products, which is 2, minus number of moles of gaseous reactants, which is 1 plus 3. So the value is going to be minus 2. Now I'm going to use the relation delta H is equal to delta U plus delta Ng RT. Yes, delta H is going to be equal delta U. Delta U we know, we do not know. Delta U means delta E, right? Delta Ng is going to be minus 2 RT, right? So I can say from this equation I can conclude you need to subtract this 2 RT from delta U, then only it becomes equal to delta H, right? So I can say delta U is greater than delta H, or delta H is less than delta U. Delta H is less than delta U. That means delta H is less than delta U, yeah? Option B is supposed to be the correct one among all, yeah? Right? Exactly, guys, exactly. Okay. Let's move on to one more question, guys, which is on your screen now. Okay, the enthalpy change of the reaction does not depend upon. Let me know fast, what do you think should be the answer right now? Yes. Let me know fast. It's very simple, guys. Enthalpy change of a reaction does not depend upon. Tell me fast in the chat box. Absolutely, it does not depend on the nature of intermediate steps, right? Enthalpy change, since enthalpy is a state function, right? It only depends on initial and final state. It does not depend on the intermediate reaction steps. That's it, right? So option C is going to be the correct one among all, right? We know enthalpy is a state function. It only depends on the initial and final state, right? It does not depend on the intermediate steps which are involved in the reaction, right? So option C is going to be the correct one among all. All right, let's move on to one more, guys. Let's move on to one more. Let me know in the chat box. Let me know in the chat box fast. Again, a very simple and ordinary question, and this question was asked in your JEE, guys. Trust me on that. 5 moles of an ideal gas at 1 bar and 298 Kelvin is expanded in vacuum to double the volume. The work done will be. What do you think should be the answer fast? Well, Moses is saying it should be C. Javed says it should be B. Pramesh says it should be D. What about the rest of the people? I want answers from every single guy right here. Rashi says it should be D. Pramesh says it should be. Amir says D. Raghu says it should be D. Well, Hari says it should be B. Okay. So let's get to know what the answer is. Well, people, as for the question is concerned, we are doing the expansion, right? We are doing the expansion in vacuum, right? In vacuum means external pressure is 0, right? External pressure is 0. We know W is equal to minus P external delta V. If external pressure is 0, that means W value is 0, right? That's what I was supposed to calculate. Work done in the free expansion, guys. Work done during free expansion, right? That's always 0, correct? I hope you remember that. It's going to be 0. Okay. Let's move on to one more question which is on our screen now. Okay. The process has delta H this much, delta S is equal to this. Out of the values given below, choose the minimum temperature above which the process will be spontaneous. Well, I can solve this question from the concept of Gibbs free energy. For the process to be spontaneous, it's delta G. For the system at constant pressure and temperature must be negative. Yes, it must be negative. It should be less than 0, right? It should be less than 0, then I can say the process spontaneous. Now, people, as you all must be knowing, delta G is nothing else delta H minus T delta S. This term should be less than 0, right? Now I can say delta H should be less than T delta S, then only the process is going to be spontaneous. Or I can say something like this: T delta S should be greater than delta H, or I can say temperature should be greater than delta H divided by delta S, then only the process is going to be spontaneous. Now, what is the value of delta H which is given to me? That is 200, right? So it's 200, right? Delta S, how much is that? Delta S is 40. 200 divided by 40 means 5. So I need to keep the temperature greater than 5 Kelvin, then only the process is going to be spontaneous, right? The process, the minimum temperature above which the process will be spontaneous, right? Yes, I need to keep the temperature above 5 Kelvin, then only the process is going to be spontaneous. So it's going to be 5C as the answer, yeah? Right? Absolutely, right? Okay. Well, people, one more question. During the compression of a spring, this year, 2020 JEE, during the compression of a spring, the work done is 10 kilojoules and 2 kilojoules escape to the surroundings as heat. The change in internal energy, a very simple and ordinary question, guys. Kill it. Let me know the answer fast. See, we know delta U is equal to Q plus W, right? Delta U is equal to Q plus W. Now, since this is the case of compression, during compression work is done on the system. Right? So, how much work is done? 10 kilojoules. And whenever work is done on the system, W value is taken to be positive in chemistry. So, it's plus 10 kilojoules, right? And Q, guys. Q is the heat exchanged. Now, 2 kilojoules escape to the surroundings. That means system has released heat. Whenever system releases heat, Q value is taken to be negative. So it's going to be minus 2 kilojoules right here. Correct? So delta U will be equal to minus 2 plus 10 kilojoules. It's going to be 8 kilojoules. So delta U is going to be 8. Option C is the one, yeah? It's very simple, guys. See, we know during compression work is done on the system, and whenever work is done on the system, W value is taken to be positive. So W is equal to plus 10 kilojoules, right? Plus 10 kilojoules there, you can see on the screen, plus 10 kilojoules, correct? At the same time, heat is released by the system, and whenever heat is released by the system, Q value is taken to be negative. That is why I took the Q value negative, W value positive. As per the first law of thermodynamics, delta U is equal to Q plus W. So I can get simply delta U is equal to 8 kilojoules right here. Yes? right? Yeah, exactly guys, exactly. It's going to be option C as the correct one, and this question was asked this year 2020, right? Well, one more question. The combination of plots which does not represent the isothermal expansion of an ideal gas. What do you think should be the answer? Let me know in the chat box. Let me know in the chat box. The combination of plots which does not represent isothermal expansion, right? People, during isothermal process of an ideal gas, temperature is kept constant, right? If temperature is kept constant for a fixed amount gas, can we use the Boyle's law? Yes, we can use the Boyle's law. And as per Boyle's law, P is equal to K divided by V. Yes. So if I want to plot a curve between pressure and 1 by volume, can I say it's going to be P versus 1 by V is going to be a straight line passing through origin. So this is the correct one. This is the correct one. First one is the correct one. Yeah. Now P versus V. These are inversely proportional to each other. The curve should be hyperbola, but it's a straight line. So this cannot be the answer. I mean, this is not the correct one. PV versus V, absolutely. At constant temperature, on changing the pressure, the product of pressure and volume never change, because we know as per Boyle's law, PV is equal to constant. On changing volume or on changing pressure, the product of pressure and volume does not change. So this one is the correct one. This one is correct. This one is correct. This is incorrect. Now what about this? Internal energy versus volume. People, if you remember, for the ideal gas, internal energy is the function of temperature only. On changing the temperature, internal energy of the ideal gas changes. Internal energy of an ideal gas does not change on changing volume, right? So this one is wrong as well. Now what are we supposed to check? The combination of plots which does not represent isothermal. It's going to be B and D. Now check which option is there, B and D. Option A is the one which is going to be correct one among all. Yes? Right. Simple. By just using the Boyle's law, I've solved this question, guys, because it's mentioned the process is isothermal, right? It is the isothermal expansion of the ideal gas. So it's going to follow the Boyle's law, right? Right. Very simple this was. Well, I think this was the last question of our session. Let me check. Yes, guys, this was the last session. This was the last question. I'm damn sure, guys, your entire thermodynamics would have got revised by just solving these 15 questions. I'm sure about this, yeah? Well, this was all from my side in today's session, right? Tomorrow we are going to do one more session, one more last minute revision from the chapter solid state at sharp 5:30. Do not miss that at all. Do not miss that at all, right? And at the same time, for the ones who joined us late, let me give the brief introduction about the Vedantu JEE 2021 crash course, which we have started on the actual Vedantu platform. Well, people, the first benefit of this crash course is going to be you can get trained by the teachers of your choice, yeah? It's going to be your wish to select the teachers, get trained by them personally, right? And at the same time, we are going to cover your whole syllabus before your JEE 2021. Apart from that, there is no need to worry about the mock tests, about the test series. Everything is included right here in this crash course. And at the same time, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers. Yes? And people, there will be some extra sessions regarding the time management, regarding the tips and tricks by means of which you can solve your questions in lesser time. Yes? And how to get enrolled in this crash course, there's a link in the description box of the video. I want you guys to click on that link. And if you want me to personally train you in chemistry, do not forget to use the coupon code as WSCC. Use the coupon code WSCC if you want me to personally train you for the upcoming JEE in chemistry, right? Well. Talking about the Eklavya batch, which we are starting on the actual Vedantu platform, which is for the JEE advanced students. This is the course detail, guys. There will be 70 live sessions, right? And there will be 3,000 plus advanced level questions which will be solved, right? And there will be 18 JEE advanced tests, 6 JEE mains tests, and at the same time, these are the dates wherein we are going to start the batch. On 8th March, we are going to start the first batch for Eklavya, 19th, second batch, 1st May, third batch, and 29th May. So there are going to be 4 batches for this Eklavya program right here. You need to submit your details by clicking on the link which is there in the description box of the video in order to shoot the bullseye for the JEE advanced with us. Yes? And there is one more link in the description box of the video, that is for the Telegram. Do click on that link as well, get added to the Telegram group and stay updated about the classes, right? And people, do not forget to like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, right? Well, this was all from my side in the tonight's session. I'll see you guys tomorrow at 5:30. Till then, you guys take care. Bye-bye. God bless you all. Love you all. See you tomorrow at 5:30. Bye-bye.